day 3. Well, actually, it's day 4 because day 1 was 2 days, day 2 was 1 day, and day 3 is 1 day. That sounds strange. Anyway, it's the third, notes 3. It's day 4. Half-angle identities. Intro. The half-angle identities are not as useful in calculus as the double-angle identities, but we do need to know them in pre-calc, and because they're not as useful in calculus, that's the motivation for what we give you to memorize, or what we give you versus what we expect you to memorize. Like the doubles we use in calculus, so we want you to know those. The halves, we don't really use these in calculus, so we will give you these since you don't need them often. This is one of those where we hear you when you say, why don't you just give them to us? We can look them up. I'm like, yeah, you're right. So we'll give them to you. Sine of 1/2 x is plus or minus. And that's kind of a big deal for these. Square root 1 minus cosine x all over 2. Cosine of 1/2 x plus or minus big square root 1 plus cosine of x all over 2. So super similar formulas. The only difference is the sign in there. Again, we'll give them to you so you don't have to worry about how to memorize and which one's which. Tangent. Usually tangent is the hardest of the 3. But for this one, it sort of works out like it's like 2 hards make an easy kind of thing. 1 minus cosine x over sine of x. Again, you're going to be given those, so you don't have to memorize them. Since you will not need these in calculus, you don't need to memorize them. They will be provided for you. Now, the big deal with these, they're just, in some ways, they're just like all the other formulas. Like, draw the picture, plug it in, work it out, no big deal. But these have an extra layer on them, and that's the plus or minus, because it is not both plus and minus. It is plus or minus. And so the big deal is, the tricky part of the identities is finding the correct sign. I would put tricky in quotes because it's really not tricky. It's tricky that you remember to think about it. The formula sheet just says plus or minus. And so for a few people that don't take any notes, he's not even listening now, a few people who don't take notes, they say, oh, I'll just look at the formula sheet. Oh, there's plus or minus. I'll write the plus or minus. No, you have to pick the correct one. You have to pick the correct sign. So let's talk about picking the correct sign. If x is in quadrant 1, then which quadrant does x over 2 lie? Because the formula is about x over 2, and so we've got to figure out where x over 2 lies if we know where x is. Well, quadrant 1 means x is between 0 and pi over 2. So if we want to know where x over 2 is, we're going to do something that we don't often do, and that is multiply a inequality by something, especially when it's already solved for x. So 0 less than or equal to x over 2, that's what we're looking for. Less than or equal to pi over 4. Well, if x over 2 is between 0 and pi over 4, picture if it helps. So if x over 2 is in there somewhere, what quadrant is that in? That's definitely in quadrant 1. It's like in half of quadrant 1, but we don't even talk like that. It's in quadrant 1. If x is in quadrant 2, whoops, so that wouldn't be 0. That would be from pi over 2 to pi. That's what quadrant 2 means. Why don't you try this one? Multiply everybody by a half and see where x over 2 lies. Picture might be helpful, but it's not necessary. Most of you have multiplied by a half, but also take the next step and tell me where x over 2 is, what quadrant. Good, all the answers I've seen so far are correct. So this is right. So think about where that is. Whoops, I left it running. Sorry for you guys watching at home. Pi over 4 less than or equal to x over 2 less than or equal to pi over 2. So from pi over 4 to pi over 2, pi over 4 to pi over 2, that would be, that's still quadrant 1. It's like the top half of quadrant 1, but quadrant 1. Quadrant 3 would be from pi to 3 pi over 2. And then do the same thing on that one. Multiply by a half. See where that lands you. So again, multiplying by a half is pretty easy. Then it takes a little bit of thought. Where is pi over 2? Where is 3 pi over 4? So if we're in there somewhere, that would be quadrant 2. So there's a couple ways to do this. Let me finish this out, and then I'll tell you the 2 different shortcuts that you might think about. So quadrant 4 is from 3 pi over 2 to 2 pi. So multiply by a half. 3 pi over 4 to pi. 3 pi over 4 to pi, that'd still be in quadrant 2. Okay, so there's like 3 ways to do this, and it doesn't really matter which way you do it. One way is to do this every time. Probably not the best, certainly not the quickest way. Another way is to memorize. Quadrant 1 goes to quadrant 1, quadrant 2 goes to quadrant 1, 3 goes to 2, and 4 goes to 2. That's not a lot to memorize, but it's kind of eh. Here's the last way. It's sort of a middle way of half memorizing, half working things out. If x is in quadrant 1, this is very fuzzy math, so you won't find this in a textbook anywhere. This is illegal. Well, it's not illegal, it's just fuzzy. If x is in quadrant 1, then if I divide both of those by 2, this looks a little bit weird. X over 2 is in quadrant 1/2. Just doesn't really make sense. But if you round 1/2, you get 1. This is how I do it. I just divide the quadrant number by 2. If x is in quadrant 2, this one works really well, then x over 2 is in quadrant 1. As long as you know how to round, it works. If x is in quadrant 3, then x over 2 is in quadrant 1.5, which doesn't really make sense, but 1.5 rounds to 2. And lastly, if x is in quadrant 4, and we divide both sides by 2, again, divide both sides by what? This is a weird thing to be dividing by 2. X over 2 is in quadrant 2. So, do it the long way, memorize, that'd be the shortest way, or you kind of come up with this sort of hybrid approach that's borderline illegal, where you divide the quadrant by 2 and then round, and it works. So this is usually how I will work the problem. That way I don't have to memorize anything, but I also don't have to write out a bunch of stuff. You can divide the original quadrant and then round, and you got the new quadrant. Right. That was a lot of talk about just getting the sign. After you find the sign of your answer, then find the value using the identity, using the formula. So we saved this one for last not because the formula is really that hard, it just has that extra step of figuring out if it's plus or minus. Example 1. Given that sine of x equals negative 12/13 and x is between pi and 3 pi over 2. So forget about what we're going to ask. What do you think we should do with that information? And draw it. Same thing we've been doing. Draw a picture of that. So pi to 3 pi over 2, that'd be quadrant 3. Sine is opposite over hypotenuse. 5, 12, 13. Negative 12. So this is x. Let's be careful here. So x is in quadrant 3. That means x over 2 is in which quadrant? X is in quadrant 3. If I divide that by 2, what quadrant do I get? Quadrant 2. Quadrant 1.5, which is not really a thing, but quadrant 2. So x over 2 is in quadrant 2. So I'll use that when I start thinking about sines and cosines. In fact, I can do that right now. The sine of x over 2, forget about the formula. Is it going to be positive or negative if x over 2 is in quadrant 2? If the sine and this angle's in quadrant 2, it's going to be positive. What about the cosine in quadrant 2? That would be negative. And the tangent should be negative, but I don't have to worry about it. The tangent is the one that takes care of itself. So it should be negative, but that should happen on its own. All right, the formula for sine. Oh, thank you. The 5 should be negative. The formula for sine is 1 minus cosine of x over 2. So we're going to get some more algebra practice here. So what's the cosine of x? Negative 5 over 13. Ooh, fractions and fractions. What could I multiply through by to make the 13 go away? That's kind of the answer. 13. So I'm going to multiply the top and the bottom inside the radical by 13. Because that will fix the 13 problem. So I've got 13 plus 5 all over 26. Yes?
Would you also multiply by 2? Or would it be like multiple?
It would be more, like, are you thinking to fix the square root of 2 in the bottom?
Yeah. Oh, yeah, it's a square root.
So, yes, but this is the easier way to go. It's like clear out the fraction first, then worry about the square roots. So that's square root of 18 over square root of 26. I split it up because I can simplify one of those. Can't do anything with the square root of 26. But the square root of 18, let's see, that's 9 times 2, so that's 3 root 2. Wait a minute. Yeah, this will work. I could have reduced first. Like the 18 and the 26 will reduce. The 2 and the 26 will now reduce. So either way. So 3 over square root of 13. I'm trying to think why this doesn't look like the answer key.
Pretty sure you did the same one first.
Because the answer key person did not reduce correctly. So I feel I'm still good. My answer key's wrong. No, still not done.
You have to make it 13.
I can fix the root 13, but that's easy. 3 root 13 over 13. And it was positive, so this one's the hardest of the three, or hardest of the three, because you got to pick the plus or minus. There's fractions you got to fix, and there's square roots you got to fix. So this problem is like 1 part pre-cal, maybe 2 parts pre-cal. Draw the picture, write the formula. That's the pre-cal parts. But then algebra, 3 or 4 parts algebra. All right, the cosine formula, that one's 1 plus cosine of x over 2. And we already said it's negative. So 1 plus cosine of x is negative 5/13. What do you want to do to fix that one? Multiply top and bottom by 13. So 13 minus 5 over 26. So that would be 8 over 26. Here's what I meant to do last time, is reduce. Well, it doesn't matter. You can simplify the square root thing first, or you can reduce first. It doesn't matter. Most of us are probably better at reducing, so let's reduce first. So that would be 4 and 13. Oh, that was a great move. That worked out easy, because what's the square root of 4? 2. So negative 2 over square root of 13. Negative 2 root 13 over 13. Lots of algebra. Tangent is 1 minus cosine over sine. So 1 minus negative 5/13 over negative 12/13. Algebra all-stars, what would you like to multiply by to get rid of the fractions? Multiply everybody by 13. We end up with 13 plus 5 over negative 12. So 18 over negative 12 would be negative 3/2. We already knew tangent was going to be negative, so that's a good check that it worked out. I would also be okay with, if you said tangent, if you didn't want to do that formula, if you wanted to do sine over cosine. And maybe you can tell that all of that stuff, if you did keep it, change it, flip it, sine over cosine would reduce to negative 3/2. So you sort of have two options on tangent. You can use the formula, well, you can use the half angle formula, or you can use the definition of tangent, sine over cosine. Let's try number 2. Cosine x equals negative 3/5, and x is in quadrant 2. Well, I know where to draw it then, for sure. Let's see, cosine is adjacent over hypotenuse. So what's my missing side? 4. Positive or negative? Positive, because it's going up. Let's see. So x is in quadrant 2. That means x over 2 is in quadrant 1. Divide everybody by 2. We're in quadrant 1. Everybody's positive in quadrant 1, so I don't really have to worry about things on this one. Square root 1 minus cosine x over 2. So 1 minus negative 3/5 over 2. What don't you like? Don't multiply by 2. Let's fix the 5s by multiplying by 5. So that would be 5 plus 3 all over 10. That would be, see how many algebra steps can we do at once? One algebra step at once. 8 over 10. What's 8 over 10 reduced to? So yeah, some of you are skipping steps on me. 4/5. But that's 2 over root 5, and then we fix it, 2 root 5 over 5. Again, most of the steps on these problems are algebra steps. But they're easy out. They're supposed to be easy algebra steps. Multiplying by 5, adding numbers, reducing fractions, fixing square roots. It's supposed to be stuff that we can handle. Famous last words. 1 plus cosine over 2. So 1 plus negative 3/5 all over 2. Why don't you see if you can finish that one from there? So multiply through by 5 to clear out that 5. Make sure you distribute it to everybody in the top. 5 minus 3 is 2. 2 times 5 is 10. 2/10 reduces. So 1 over root 5, which becomes root 5 over 5. And, oh yeah, we were in quadrant 1. I'm checking at the end as well. Quadrant 1 should be positive. They all should be positive. For tangent, do you want to use the formula or do you want to use sine over cosine? Use the new one. I think we should use the new one. That way, if you get asked to do tangent without having done sine or cosine, you can jump straight to it. But I'm pretty sure some of you might be able to see of those, sine over cosine. We'll see what happens. 1 minus negative 3/5 over 4/5. So again, clear in fractions. Lots of clear in fractions this unit. 5 plus 3 over 4. Well, that was pretty easy. I don't know if the other way would have been any easier than that. Let's just do the first part of number 8. And the first part, I mean, draw the picture. So see if you can draw the picture for number 8. So you switch it to cosine. Cosine's positive first and fourth. Let's see. 9 minus 4 is 5. Right, that's not a 2, 3, 4 right triangle because there is no such thing. I have made a mistake here though. What's not right? It needs to be negative. I think it turns out that it would matter for tangent. It wouldn't matter for these two. Alright, if x over 2 is in quadrant 4, no, x is in quadrant 4, which means x over 2 is in quadrant 2, which means cosine is, well, let's go in order, which means sine is positive and cosine is negative. Take care of those right away. 1 minus cosine x over 2, 1 plus cosine x over 2, 1 minus cosine over sine. I don't think we need to do those because they work exactly the same way as the other 6 examples that we've done work. So your assignment today, we're done with notes, yay. Your assignment today is worksheet 4, the half angle identities. And again, tomorrow's assignment, Friday, is to work them in class. Maybe even finish in class, that'd be great. And Monday I'll take questions. And then Tuesday we will test. Again, I'm out tomorrow, but I'll be back Monday to review. So tomorrow is your review, Monday is my review, Tuesday is our test. It's not really our test, right? I'm not testing, it's your test.